Okay. All right, good. All right, here we go. Let's see if this shows up. Okay, maybe not. Alrighty, here we go. All right, see if that should show up on the stream. Okay, there we go. I got it. Cool. Okay, good stuff, good stuff. Okay. Alrighty, good, good, good. Okay, there we go. All right. Hello, everyone. Hello, hello. Hey, how are you, Natalie? Hi, good morning, Sion. How are you? I'm doing really well today now that I finally have my computer back. Oh, good night. Oh, Rohan, good morning, my friend. How are you? I hope you are doing well, my friend. Yeah, so a lot of my Windows system files got corrupted on my main M.2 drive, so I couldn't stream for the past 2 days while I had to get emergency repairs put in. That's basically what happened the past couple of days. So I haven't been able to do a whole lot. I got like a new kind of semi-used laptop, but yeah, it kind of pales in comparison to when have you all your streaming and knowledge tools and all your documents all on the main computer. So yeah, it was a little rough go for a little bit, but now I'm back. Yeah, I'm very glad my computer is finally back to normal in some capacity or form. I'll take that any day of the week. So, I mean, I'm not going to sit here and complain. I mean, it does exactly what it's set out to do, but I didn't need it to crap out, you know? That was pretty bad. Um, so, I mean, things like that, kind of important, I think we could all agree. Nice. Congratulations, man. The video looks more clear. That's good. That's good. Yeah, a lot of maybe a lot of things got cleared out. I've had to update a lot of stuff yesterday to be perfectly honest. So maybe it's actually better this way. I don't know. We'll see how it goes, right? All right. Now, want to let's go ahead and do that. Okay. Hopefully you guys are ready now. Again, let's go ahead and get started here. Okay, let's get started today. Welcome back to Friday, or what should have been Thursday, but now is Friday. First of all, I want to really apologize to you. I don't make it a habit to obviously cancel classes. Um, yeah, I'm really sorry that my computer absolutely kind of blew a gasket, and yeah, obviously I don't want to miss classes. I hate missing classes. I hate missing time spending with you guys. But hopefully today will be a nice little makeup effort for you guys to learn any of the new material for upcoming sections. So we're going to pick up where let's go ahead and get started here, and we're going to pick up where we left off last time. And so let's talk about that here first and foremost. All right. So where we left off last time, and I know it's been an extra day more than normal, but where we left off last time was talking about how to add and subtract numbers, fractions in particular. And so today what we're going to be doing is we're going to be adding and subtracting again, only this time we're going to be doing it with mixed numbers. Okay, so that's the goal here for today, is to add and subtract with mixed numbers here. So let's go ahead and do that right now. Okay. All right. So adding and subtracting mixed numbers is not going to be sure. I'm using math type, Rohan. All right, so adding and subtracting mixed numbers, we're just going to follow some steps here, and we're going to put it all together here. So let's go ahead and take a look here at each step about how to add and subtract some mixed numbers. All right, step number 1, convert the mixed number into a improper fraction. Okay, so just like we had from before, all right, where we turned mixed numbers into improper fractions, do multiplication, division, or whatever. Well, okay, let's do the same thing. And that'll lead us here to step 2. Step 2 for us is going to be in relation to, again, find the common denominator. Okay, so you're going to find that common denominator once you put that together. Step 3, again, same thing as we talked about last time. Multiply each denominator by a number. So we have the same denominator. We have the common denominator in each fraction. Again, let's not forget, don't forget to multiply the numerator by the same amount. Remember, balance, all right? And then step 4 is then, again, going ahead, either add, subtract the numerators. Add or subtract the numerators, and again, and convert back to a mixed number. I should say reduce if necessary, and then convert back to a mixed number. So really the only difference here is the first step and the last step. So we convert to an improper fraction, then we convert back to a mixed number after possibly reducing stuff down, and there we go. Not too bad. There it is. Okay, now let's go ahead and take a look here, and let's do this here. All right. I've been doing some digging around. All right, so let's go ahead and do a little few examples here. All right, of adding and subtracting some numbers. Okay, so we're gonna bring up this this dude. So, all right, I'll bring up the Word document back here in just a second. Okay. All right, I'm just gonna write the first example down here. So let's try and find that first one there, 16 and an eighth. So we'll try 16 and an eighth plus 5 and 5/8. All right. Did that do anything? I hope so. Anyway. Um, hmm? Well. All right, there we go. Okay, so here's our 16 and eighth plus 5 and 5/8. All right. Let's go ahead and take a look here. Now, in this case, it's not so hard, but you'll see I'm going to go through the same process here nonetheless, just to showcase exactly how we should add or subtract mixed numbers. Okay, so let's take a look at each one here. All right. So let's convert 16 and 1/8 into a, how is that E? What? Okay. Never mind then. All right, so let's look at 16 and an eighth. I'm gonna fool around a little too much here if I'm not careful. Okay, can we convert 16 and 1/8 into an improper fraction? What would that be? What would 16 and 1/8 be as an improper fraction? Again, it's okay to use your calculator for this. So again, go ahead and put that in the chat there once you're ready. 129 over 8. Okay, good. That's right. All right. And we'll also do 5 and 5/8. Okay. So how about 5 and 5/8? What will that equal as an improper fraction? Forty-five over 8. Excellent. Nice job. Okay. Now all we're going to do is take 129 over 8. All right. So this is pretty big. All right. Probably needed a tad bit smaller here. Let me put the size down here a bit. Maybe still a bit big. Sorry, I'm just trying to find some space here for you guys. All right, there we go. Okay, so let's add these together now. All right. So we're going to take 129 over 8. All right. Plus 45 over 8. Okay, now as you can see here in this case, because it's not going to apply to every case, but in this case here, we do have like fractions, okay? We have the same denominator in each. We normally would find the common denominator here, but I wanted to showcase about, kind of the first easier kind of example here in this instance. So essentially, we put that over 8, and then we're going to end up with an answer here. So let's go ahead and do that right now. All right, so we're going to do, again, just from last time, we're going to take 129 plus 45. Remember, that's going to be all over 8. So what do we get here if we add those together? Okay, 175 over 8? I think we're one off there. Yeah, 174. Because the 9 and the 5 are 4. So, yeah, just one off. No big deal. Cool. All right. Okay. Now it's at this stage here that we want to take this number, no matter what it looks like here. Okay, we want to be able to reduce it down if necessary, okay? So the question is, can we reduce this number down before we do anything? Can we divide the numerator and denominator by a similar factor? Yes, okay. By what number? Okay, so let's divide by 2. Okay, good. So we're going to divide by 2 here on the numerator, and we'll also divide by 2 here on the denominator. So that's going to net us. Perfect. You guys are doing really well. Now again, I know, how did I know it was 2? Again, it's because of the fact that the numerator is an even number and so is the denominator. So just start off with something basic, and then hopefully you can work your way down to, something that maybe you can work with a little later. So it's the way I always do it too. So we get 87 over 4. All right. Now I could tell you that's not reducible, but now we want to convert this into a mixed number. So you do the regular division as you do. And can anybody tell me what 87 over 4 would be as a mixed number? All right, 2 and 7. Okay, so yeah, 21 and 3/4 is correct. So 21 and 3/4 is correct. Let's show that off here once again. Okay, just to refresh everybody here. See if I have the paint tool here after all this time. I don't even know, because all right, there, I actually do. Cool. All right. So to highlight this one more time, to give you a friendly reminder, remember when we take the 4 here on the outside and put the 87 here on the inside, that goes in 2 times. So 4 times 2 is 8. So we may have a 0 here. 8 minus 8 is definitely 0, but one thing to remind yourself of is that this 7 still comes down, regardless. That 7 still comes down. So because the 7 still comes down, I have to figure out how many times 4 goes into 7, which is going to be once. And then I get the 4 here and the remainder of 3 in this instance. So here we get 21 and 3/4 here as our mixed number here for this problem. I hope that part makes sense there. So now hopefully that'll make it a little bit more clear. All right, any questions about that one? We're gonna do another problem, but make sure everybody's clear on that. Again, if you have no questions, type no in the chat. If you have a question, please type it out. No? Okay. Robert, my good friend, how are you today? All right. All righty. I see Eric and Jonathan. How are you guys doing today as well? Mr. Martin, how are you doing today? Okay. I'm going to go ahead and I'm doing very well, my friend. All right. I'm going to go ahead and do another example here. All right. Sure. Let's look at this next one here. 8 and 5/8 minus 3 and a 12th. All right. All right. So now this time though, we are going to end up with different denominators. Okay, so let's look at this a little bit more clearly, okay, and see what we get here. So let's go over each mixed number here. We're going to convert that into an improper fraction. All right, let's start off with 8 and 5/8. I'll set up 3 and a 12th here. 8 and 5/8. What's that going to be? What's 8 and 5/8 as an improper fraction? 69 over 8. Good. Okay. Is everybody seeing how we get the improper fraction here? I hope everybody understands where we're getting the 69 over 8 from. Are there any questions about that part once again? Okay. Okay. How about 3 and a 12th? What's that going to be? No? Okay. Just making sure. How about 3 and a 12th? What's that going to be as an improper fraction? 37 over 12 is correct. Good. All right, so 3 times 12 plus 1, all over 12, will be 37 over 12. Now let's go ahead and put this together. Okay. So we're going to take 69 over 8. So this is again, that was the first step. Now we'll need to do the second step because now we have different denominators. So now we have different denominators. Okay. So with different denominators, we're going to need to find the common denominator. So can anybody tell me here? Let's recall what we did earlier this week. It's kind of weird to say, but okay. Kind of weird to say when it's Friday. But what is the common denominator between 8 and 12? So the common denominator between 8 and 12. Yeah, that's right. 24. Very good. All right, so maybe you tried 12. 8 didn't divide into 12, but maybe you tried 24. Remember, we always start at the biggest number. We always start at 12. We go up, and go up to 24. 8 divides 24, so that's our winner. Okay, great. Okay, so I need to multiply 8 by something. So what should we multiply 8 by to get 24? All right, 3. So 8 times 3 is 24. Okay, well, I multiplied that by 3. What else do I have to do? If I multiply that, okay, very good. That's right. So remember, we talked about balance before. So we multiplied the denominator by 3, so we have to do the same to the top as well. You have to multiply the numerator there. Okay, great. How about the next one? How about 12? What should we multiply there to get the denominator of 24? All right, times 2. Good. All right. Of course, that means to multiply by 2 here. Okay. Now let's take a look at each fraction here, respectively. So we got 69 times 3. Now, if you did that out, you could do that, just doing regular multiplication here, and that isn't too bad. Okay, so we're going to get 207 over 24. And we're going to subtract that by 37 times 2. So that's going to be 74. 74 over 24. All right. So we're going to subtract these from each other. And can anybody tell me what we get here? Okay. 133 over 24. Okay. Now, let's say you didn't know whether this reduced or not, and that's perfectly fair. Okay. Um, then let's go ahead and take a look here at the mixed number. Okay. We're just going to do the mixed number here. All right. So if you need to do it by hand or you want to find out how many times it goes into, again, with bigger numbers, I understand. So this goes into, let's see, how many times? Might be 5 times, I believe. So, but I'll go ahead and check that real quick. You guys can do that with me as well. So I think that's 5 times. It doesn't go into 13. It goes into 133, so 5, that's going to be 120. That's right. Okay, and we get a remainder of 13. So our final answer here is going to be 5 and 13. 13 over 24, which does not reduce. So here's what can happen here. And, if you convert back into a mixed number, and let's say this fraction is reducible, then reduce it from there. If you want to reduce it beforehand, like we did in the last example, you can go ahead and do that as well. Okay, so you do have options on the table there should you want to go down that path. All right, are there any questions about this example before we move forward? Any questions at all? No? Okay, cool. None from you? Excellent. Okay. All right. Now, let's have you guys give a problem a try. Okay, so a little bit of participation. It's okay. I would understand that my voice is very drolly. It does. It drolls on forever and ever and ever. Sorry about that. Okay, let's have you try something. We'll do this one here after you guys try that one. So let's try this one here, 8 and 1/3 minus 4 and 3/5. We'll do that in this case. So I'll give you guys a minute or two to go ahead and do that. Let's see if this works, shall we? I just need to test out one more thing, you guys. I'm going to see if this works while you're working on that. So bear with me here. I guess not. Okay. I had to check to see if that worked or not, but I guess that's a no. All right. Apologies. Still trying to work out smooth out the wrinkles. All right. Okay, so let's see. Again, post your answer there in the chat once you got that put together. And we're going to go ahead and go over it together here and see what you guys got, okay? So I'll give you 30 more seconds here, and we'll go ahead and give it a go. It's okay. I totally understand. I know it's a Friday. I know this is not what you expected. I totally understand that. I am not going to trust me, Patricia. I am not I'm not upset at all. It's really me you should be upset about. That's kind of a thing. So I do apologize. It's uh it's on me. 56 over 15. Okay. Let me see if you guys can hear this. Okay. Maybe not. 56 over 15. All right. So let's check it out to see if it's 56 over 15. So the first fraction here, 8 and a third, can be put as 25 over 3. All right, here we're going to subtract 3 and 11/15. All right. We're going to subtract here by 4 and 3/5, so that's going to be 23 over 5. Now, as was correctly stated by Jonathan there and by the others, again, we want a common denominator here. And that common denominator here is going to be indeed 15. So common denominator here, 15. All right, so if we want a common denominator here of 15, then we multiply this first fraction by 5. Again, on the numerator and denominator. Thanks, McDaddy. Then we multiply this second denominator here by 3 on both the numerator and denominator. So we got that. Good to go. All right, so let's take stock of what we got here. So we got 25 times 5, which is 125 over 15. Minus, looks like 23 times 3, which is 69 over 15. All right, and correctly stated here, that is definitely 56 over, oh, that should be 15 there. That should be 56 over 15. And so converting that into a mixed number, correctly stated here by Jonathan, good, 3 and 11/15 would be your final answer for that. Nice job. All right. That wasn't so bad. Easy peasy, lemon squeezy. Ba-bam. We have a winner. Any questions about that? Nope. You're like, this is so simple. Oh man, it's so easy. Holy cow. No. No. Like, nah, bruh. No. All right, cool. That works. No. Like, yeah, it's so simple. I don't need to do crap anymore. Oh my god. Okay. Okay. All right. Let's talk about a couple more here. And this was a problem that was kind of asked to me a little earlier. So I do want to kind of point out one thing. This is the way you would get the exact answer, for example, like 3 and 11/15. But another part of the problem that you may see in the homework, and I'm just going to acknowledge this now, is like estimating what the answer would be, for example. So I'm just going to talk about that really quickly. All right, there's not a lot to estimation for fractions. So I'm just gonna kind of mention it here. Honestly, estimating is okay. It gives you a general idea about where you should be looking at, but not the greatest thing in the whole wide world, mind you. So in any case, if we're going to estimate fractions, you only round up if the fraction is 1/2 or, yeah, 1/2, that's a nice thing. Okay, that's nice. 1/2 or above. So if the fraction is less than 1/2, then keep the number the same. Okay, so what does that exactly mean? Well, let's take a look. In the last problem here, we had 8 1/3. Now, if you figure out 8 1/3 here, specifically, I'm looking at the third part. And all I have to do is determine whether or not a third is either bigger than or less than 1/2. Okay, so again, 1/2, another way to put that is 0.5. All right, we'll talk about decimals later, but you get the idea. Okay, so the question really is 1/3 less than a half? Yes or no? So is 1/3 less than a half? Yes, okay. 1/3 is less than a half. So yeah, you can imagine it this way. A third of a pizza is less than a half of a pizza, okay? So basically, you would round this to, let's go ahead and put that here. This would round to 8. Yes, that's nice. All right, this would round to 8, all right? That actually go off? Okay, give me a second here. Let me see if that works. It does! Yay! Ride of the Valkyries, everybody. All right. All right. Now, got that to work. Okay. Now we look at 4. You're like, what the hell was that? Okay, woke me up. Friday morning, boy. We're gonna start. Yeah, okay, look. Okay, let's just do it the right way. It's Friday. Okay. Yeah, I know it's the end of the week. I know we're learning math. Okay, we'll do it. We'll do it right. I'll just start from the very beginning. Okay, and then this will wake you up. You know, I'll lower the volume a little bit so it doesn't like bleed your ears, because I would hate that too. And then we'll just do this. Everything's going so well. Oh! Onward! There you go. That's fair. That's very fair. Oh man. That's hilarious. Alright. Wait, how long does this go for? Alright, I have to stop. Alright, otherwise it's hard to hear me. Okay, let's. Alright, there's our little break there. Okay, there you go. Hopefully that's a nice little wake up call. You know, slightly a bit better than a Dunkin' Donuts. Um, you know what? You know what? I know exactly how to finish this off. This bit off here. So see, I have my water right here, and if I drink it, but since I just listen to classical music, I'll drink it like this. See? Mm. The pinky had to go up in all classical style. Perfect. So, yeah. This is very fancy, let me tell you. Oh my gosh. All right. All right. 4 3/5. Get there. We're gonna get there. 4 3/5, everybody. All right. You have to answer the question: is 3/5 bigger than 1/2? Is 3/5 bigger than 1/2? Absolutely, 100% yes. Onward, everybody. It rounds up to 5. So if you were to ask in the homework there, they say, okay, estimate the answer here. It would be 8 minus 5, and then that would be 3. So that's the kind of the first part of that question that it'll ask you to how to estimate in that case. Okay, otherwise, if it just asks you for the exact answer, you now know the steps about how to do so. All right? Are there any questions about adding or subtracting mixed numbers? No, they say. All right. Alrighty. So let's take a good look here at the next section here. Okay, now the next section here is talking about order relations and order of operations. Okay, so we're going to discuss about this section here in a little bit more detail. All right. So, I want to bold here. All right. And in this section here, just to let you know, we're also going to talk about a little bit of something extra here in the next section that's related to this section here. So you'll see where I kind of fit that into this section here. It'll make the next section significantly easier to do. Okay. Now, the question really becomes is, okay, how can we compare the size of two numbers? Okay, here this is a good picture about how to compare the size of two numbers, such as a half right in between 0 and 1. 4/3 would be a third above 1. So again, you cut it into 3 equal parts, and this would be 4/3, 5/3, and then that would be the last part there. Again, fourths, 1, 2, 3. Again, we have 1, 2, 3, 4 parts between, say, 2 and 3. So that's all well and good. But what we want to focus on here in this particular section are on two things. First of all, determining what is less than or bigger than, all right, in this case here. So first and foremost here, let's look at the notation here really quick. So notation, yes. So this is going to be uh, this is bigger than, this is less than, sorry, other way around. I'm thinking from right to left. All right, this is less than, and this is bigger than. If this is too small for you, just in terms of like font and stuff, just let me know. No, I want this. Okay. No, gosh darn it. Arr. Right. Why must you torment me? You know what? You're gonna get those. All right. Alrighty, there we go. Got it. So less than or bigger than. Okay. Okay. So we're going to use this notation here to figure out which one of the fractions is going to be bigger at the end of the day. So let's go ahead and take a look and see what we're working with. Okay, so let's look at that first question right there. And that question is, I believe, is 1/2 and 4/3. We want to compare to see if 1/2 and 4/3. So let's see if it's less than or bigger than. I know it says less than, I know it says bigger than. We're gonna just use each one here in this case. And I'll put a note in relation to this in just a second. So you just have a little bit of more notes there. Okay. Okay, so we're going to compare both of these, and we're going to put either it's bigger than or we're going to put it's less than. Okay, and to fill that spot there in the middle. Okay, that's what we're going to do. All right. Now, one thing to note here is maybe you get confused about notation for less than or bigger than. Okay, remember this. Pointy end goes to smaller number, or open mouth or open mouth slash big mouth, open slash big mouth goes to bigger number. All right, so that's a little tip that I got there. Just be like, I don't know what's less than or bigger than. Well, there you go. Um, Pointy end goes to smaller number. Some people remember it back the way. Open slash big mouth goes to bigger number. You can think of it that way. Or you can imagine your friend who happens to spill all your secrets. Okay, you know exactly who I'm talking about. Okay, so just pointing that out there. All right, so if you don't have a friend who doesn't spill all the beans every time you try and tell them something, yeah, I'm not sure what you've been doing. Everybody's got that friend or that family member, and you're like, every time something major happens, you're like, psh, nah, bruh. So, which I totally get. All right. Now, here's the question. How can we compare two fractions? Now, this one is particularly easy, okay? This one isn't hard. Patricia, that's absolutely right. But how can I make for sure if it was two different fractions? Like 1/2 and 4/3 are pretty easy to compare. But what's the key here into determining bigger than or smaller than, okay? Well, the key here is very simple. The key here is to use the common denominator to make both of them like fractions. And then compare the numerators. So if we have the same common denominator, we go through the same steps multiplying and stuff, we're going to be good to go in determining what's what. Okay, so let's look at this example. Like I said, fairly simple, fairly straightforward. Now, if we were to compare 1/2 and 4/3, what is the common denominator here between 1/2 and 4/3? 6. That's correct. 6 is absolutely correct. So, for 2 here, we're going to multiply by 3, okay? And of course, we got to multiply by 3 on the numerator as well. And then for 3, we're going to multiply by 2. And we're going to multiply by 2 here. All right, because we want a common denominator of 6, which is true. So what we get here is we get two fractions. A 1/3 over 2 times 1 times 3 over 2 times 3 is 3 over 6. And then we have the second fraction here of 8 over 6. And now you can tell clearly which number is going to be bigger. We're going to compare the numerators. Okay, at the end, remember that's the key here. We're going to compare the numerators here. And so now we know that 3 over 6 is less than 8 over 6. And there we go. And then you can say for certain at the very beginning, okay, that has to be true. So there's a way we can automatically compare those two by taking all the guesswork out and yeah, just having that. Let's compare to other sets of numbers here. I think that's fine. All right. Okay. 8 over 5 and 23 over 15. That looks pretty okay. Let's do that. Well then, okay. All right. Let's try and find the common denominator here. What's the common denominator here for 8 over 5 and 23 over 15? Okay, 15. That's correct. Okay, so we multiply by 3 here. And we multiply by 3 here to get 15. We already have 15 for the second fraction, so we're going to leave it alone. All right, so we get 8 times 3, which is 24. Get that over 15. You get 23 over 15. So what's our inequality here? Are we having bigger than or less than? We have bigger than or less than? Which one? Okay, that is correct, right? 24 is definitely bigger than 23, and we're good to go. Perfect, everybody, nice. Very good. Easy peasy lemon squeezy. All right. Okay, so that part I don't think people have too much of a hard time with that one. I think that one is relatively straightforward. So, in my opinion, in my humble opinion, I think that one is relatively straightforward. Okay, now let's talk about the second half of this, because the second half of this is actually a little bit more important than comparing two fractions necessarily. That's really kind of where what I want to talk about here for most of the rest of the time here today. Okay, so specifically, we want to talk about order of operations. Okay, now we remember order of operations from last time, so let's at least talk about that here once again. All right. Oh, it froze. Okay. Oh, oh. Okay, good stuff. All right, that should work to a degree. Okay. Okay, are we back? All right. I think that's still going to be a thing. So, yeah, I'm pretty sure that's still going to be a thing. But whatever. That's no big deal. We're gonna get through it. You know, it is what it is. Yeah. You know what? I've got to see if just reducing it down to 720 maybe the thing. So, you know, it's just kind of weird. But anyway. Okay. So, let's go ahead and take a look here at the order of operations. Now, order of operations here went parentheses, okay, exponents, all right, multiply, divide. Remember, multiply, divide is the same rank, and addition and subtraction. Okay, so those are our guys here that we got. So parentheses, exponents, multiply, divide, and add and subtract. Now, the thing that we're going to focus on here after looking at PEMDAS is going to be exponents. Okay. All right, so we're going to look at exponents of fractions specifically. And what we're going to look at here is we're going to look at the rule here for exponents of fractions. And it's fairly straightforward, okay? It's not too hard. It's just, again, you just have to be sure that you take care of both parts, really. So what is the rule here for the exponent of fractions? All right. So let's do that. So let's say we have a fraction here of a over b, okay? And we take that specifically to, let's say, the nth power. So we take that to the nth power just like so. Okay. Now, if we take a over b to the nth power here, then what happens is that we basically distribute the exponent to both numbers in the fraction. So we get a to the n over b to the n power. Now this is it, of course, in general. So this is our generic rule that we got here that we use from time to time. All right, so it's not the worst thing in the world, but there you go. It is what it is. Okay, now let's show off some examples and let's see what we're talking about here in this case. Okay, let's turn that off for now. Okay, that's fine. I'm just checking to see what what that's going to be there. Okay, it probably stuttered for just a second. Okay, okay, there we go. Perfect. Okay, perfect. No. Oh my gosh. Come on, stop. Stop doing bad things. Okay. All right, there we go. Well, now I have to change everything again. No. Okay. All right, hopefully this is going to work. Okay. Glitch in the matrix. All right. In any case, um, let's go ahead and keep going here, though. All right. So let's do an example here. Here we're going to take 2/3 and we'll raise that up to the third power. Okay, so we're going to take 2/3 and we're going to raise that up to the third power. So what that's going to equal here is we're going to get 2 to the third over 3 to the third power. So if you remember how exponents work, we're just going to take 2 to the third is 2 times 2 times 2. And 3 to the third is 3 times 3 times 3. All right, so if you take 2 times 2, which is 4, times 2, which is 8. Okay. We have 3 to the third, which is 3 times 3 is 9. And 9 times 3, 9 times another 3 here is 27. So 8 over 27 would be your answer for that. Let's look at another one. Let's look at 5 over 4. So 5 over 4, we're going to go ahead and take it to the second power here. Okay. And, oops, why did that happen? 8 over 27. Why did this happen? All right. 25 over 16. That is correct. Good. That's right. So here in this case, just to break this down, we get 5 to the second power. And here we get 4 to the second power. All right, and 5 to the second power is 25. And 4 to the second power is 16. Okay, good. All right, good stuff. Okay, let's take a look here at another problem. Now there is a problem here that definitely does have a right to be there. So, okay. Now we're going to focus on these two problems here, B and C, as you can see. All right. So this is going to introduce a couple of new concepts here. So we're going to, again, there's a couple ways to do this problem, but we're going to do it, of course, the way that we know how. So let's look at letter B here. So this guy right here. Okay. Let's go ahead and do it. All right. So we're going to take 3/8. Multiply that by, we're going to have times 1/2 plus 1/3. Okay, now here's the question in this problem. What should we do first? How sum for the first one was to the third power, second one? Oh, I just, Natalie, I just made that up. Yeah, it could be to literally any power. That's what the rule will provide. So you could take any power you want and it'll still work out that way. So no problem. I'm here to help. Find the common denominator. Okay, Patricia. Find the common denominator between what fractions? Okay, very good. That's right. So we have 1/2 and 1/3. Okay, and because we have 1/2 and 1/3, okay, then basically what that means is that we need to do the parentheses here first. So 1/2 and 1/3 will find the common denominator between those two. So that's the first thing here. So common denominator here, specifically, let's go ahead and put a little text. All right, between 2 and 3. So what is the common denominator here between 2 and 3? 6. Spot on. That's correct. Okay. So what we're going to do here is we're going to multiply this by 3 on the numerator and denominator here. Spot on, everybody. Then we're going to go ahead and multiply by 2 here to get our 6. So right now, as it stands, let's take a look at our, let's take stock in what we have. So right now we have 3/8. We haven't done anything with that yet. And we have that multiplied by, and in this case here, 3 over 6 plus 2 over 6. So now putting that together here, we're going to get 3 over 8. All right. And then we're going to multiply that by the fraction of 3 plus 2, which is 5 over 6. So now, as you can see here, this is just straight up multiplication. Again, we do the same thing we've done for fraction multiplication. There's nothing brand new about how we're doing it. It's the same stuff, different day. Okay, nothing's changing in that regard. All right, so basically put, we do 3 times 5. There's nothing that reduces down in this instance anyway. So we do 3 times 5, which is 15, and 8 times 6, which is 48. 48, not 45. Well, let's see. Does that reduce? Oh, actually, I take that back. I'm sorry. I'm not smart. There is something that does reduce actually. Is this a live lesson? Yeah, but you're always welcome, man. You can ask me whatever. Actually, there's one thing that does reduce. I totally apologize about that. Yeah, I'm so sorry, Diego. You're gonna see me later today, though. Um, yeah, I got my computer back, my dude. Yeah, I know. I'm so sorry about that. I feel terrible. We're gonna divide each one by 3. So what we're gonna get here is that. So we get 1/8, and then we'll multiply that by 5 over 2. Yeah, I missed that one there. That one's my bad. Yes, sir. Absolutely. Told you I'd make it up to you. I don't like missing classes, so I'm teaching today and tomorrow. All right, so our final answer here is 5/16. All right, cool. Let's try the next one here. Okay, so this one's kind of like this one's a little trickier. Okay, and what's the rest of that problem there? Minus 4/5 times 1/2. Okay. Look, you could do what you like, Diego. If you want to come to class, that's cool, man. It's my fault that this happened in the first place. I didn't expect my computer to go kaputski. So, bro, I wouldn't hold it against you. I know if they're important, then I totally get it. Okay, so we're gonna do 2/3 squared minus 4/5 times 1/2. Okay, So I want you guys to take a minute or two and try and give this a go. Okay, remember to use um, the order of operations. Okay, so I'm going to go ahead and give you a minute or two to do that. The order of operations are on the screen here. So we'll do that here together in a couple minutes. So I'll give you guys a little bit of time to do that. Okay, cool, Diego. We'll see you a little bit later. Okay, we got 4 over 90. Just make sure, Patricia, that that reduces. If it does, then tell me what that would reduce to. Okay. Take another minute or so. Okay. Let's see if you guys got it or not. I'm going to give it a go. Okay. Alrighty. Good stuff. Okay. Anyway, so let's go ahead and do this last problem here. All right. So we're going to do 2/3. I don't know what I'm joining, Mr. Big Flakes. You can't post links in chat, so just pointing that out there. Join a Discord server for what? See, 2/3. 2/3 squared is going to be 2 squared. Okay, so remember that's 2 squared. Bruh, I don't know what your Discord server is for. It could be anything. All right, so we got 2/3 squared. We're going to figure that out in just a second. And we have 4/5 over 1/2. So we get divided by 2. So here we get, again, we get, let's put that there. Okay, so we're going to get 2 over 5 times 1 over 1. All right, so you can see how just kind of reducing stuff down is pretty helpful. Okay. So here in this case, we have 2 squared over 3 squared. And 2 squared over 3 squared is going to be 4 over 9. Okay. And then we have minus 2 over 5. Again, you could have probably, again, to be fair, if you didn't notice that you could reduce it down, you kept it as, say, 4 over 10, that would have been just as fine, okay? So it wouldn't have mattered here because, again, you reduced it at the end anyway. So if you got to that point, then that's okay. So now we want to take the common denominator here. Now the common denominator here in this case is 45. So with 9 and 5 there. So we're going to multiply 9 by 5. We'll also multiply that 4 by 5. Again, we have to multiply, if we multiply the denominator by something, we multiply the numerator by something. And the 5 here, we're going to multiply by 9. And the 2, we're going to multiply by 9. So let's see what we got. So we have 4 times 5, which is 20. So that's going to be 20 over 45 minus, and since we have here 2 times 9, which is 18 over 45. So our final answer here, 20 minus 18, which is going to be 2 over 45, which is going to be our final answer for this problem. Okay. Any questions about that problem there? Oh, that's okay. That's okay. That's what practice is there for. Okay. Now, I'm going to be making a very special announcement right now in regards to this is now the end of chapter 3. Okay, so I'm just going to point that out. We've now effectively finished chapter 3. So our next test here is going to be over chapters 2 and 3. Now, of course, because of the events about what happened here yesterday, I'm definitely taking that into account for this go around because, again, the expectation was we were going to have class yesterday and we did not. So irrespective, because of that fact, I'm not going to make the test due next, say, Thursday. That wouldn't make any sense. Instead, I'm going to go ahead and extend that out to the next class period, which would be the next Tuesday. So next, not next Tuesday, sorry. The following Tuesday. Actually, no. You know what? I changed my mind. It'll be the following Thursday after next Thursday. So it'll be 10/22 is when the next test is due. So I still have to kind of make this up because I was going to make it up the other day. Sadly, that did not happen with the computer being out of commission. So I'm going to post it up this weekend. You'll have a week, over a week and a half of which to do it. Okay. Again, a practice test will be put up once again, just like the last one. Okay, this is over chapters 2 and 3. I'm going to limit the amount of questions, of course. So I'm going to, even though it may be 2 chapters, I'm going to try and limit the amount of questions so it's not super overbearing. Okay. When you get the grades from the first test, yeah, actually I was entering those in my laptop, and then I was like, oh yeah, and then I got a call from the person saying, so I bought this laptop the other day, and then working with a laptop's a pain. So I was putting in grades for like your homework and stuff. You probably see that a little bit on D2L. Um, but then I was like, then I got caught up in getting my computer fixed and running around for the tech guy. So I was like, okay, that's cool. So yeah, I haven't been able to kind of put them into D2L, but I'll put them up this weekend for sure. Cause yeah, it's way overdue, way overdue. I know that a lot of people ask questions about that. To be fair, and you have every right to ask that. Yeah, so you know what? I'm behind on that, and I need to catch up on that. Yeah, absolutely, 100%. So, um, I'm gonna go ahead and take care of that this weekend for sure. It's a lot of work for me to do. So, but catching up is important. Uh, are there any questions about the test there? I'll make another announcement on Tuesday, by the way, because I think maybe not as many people came out today. So, which is totally understandable considering. So I'll also make an announcement on D2L. So once I get that test made up, I'll put the announcement up on D2L and send you an email. Yes, of course. Every practice test gets extra credit. If you try on the practice test, that's free points on that is definitely free points on the table. That's exactly what it's there for. And you don't have to get like 100% either. You could again, I just want you to practice and try. So it's not like it's not a race to the finish. It's just a matter of you practice and you try, and then when you do the real thing, then at least you have a good idea about what kind of questions are going to show up. So it's exactly what it's there for. All right. Any other questions? Ah, yes. Thanks for reminding me. Let me make sure about that. Yeah. Okay. That was fine. Okay. Right. Uh, homework today is sections 3.4 and 3.5. So there we go. Just had to confirm that just to be on the safe side. But there we are. Sections 3, 4, and 3, 5 will be the homework here for today. All right. Any other questions? Okay, cool. Well, guys, for those of you who came out here today, I want to thank you so much for coming out here for this special session. Again, I apologize about everything that happened, the past couple of days or so, but I hope I've at least made it up to you. I'm not going to sit here and abandon you guys. I want to be sure that you guys are taken care of. You guys have paid for a course and you should get that course regardless of what day it is. So this is hopefully my way of making it up to you. Um, so thank you again for coming on out. All right, guys. Thanks again. We will see you on Tuesday. Have a wonderful weekend, and you'll probably hear from me soon on D2L or your email. All right. Have a great one. Take care of yourselves, everybody. We'll see y'all later. All righty. Bye.